you know, most people think the hardest part of machine learning is building and training a really good model. And for a long time, I thought that too. But once you step out of the lab and into the real world, into production systems, you quickly realize that's rarely the case. The truly difficult part, the thing that keeps engineers up at night, is knowing when your model has started to fail. See, machine learning models don't fail like regular software. They don't just crash and burn. They don't throw up big scary error messages. They just keep on running, day in and day out, but they silently become less and less useful over time. It's a slow, quiet decay that's incredibly easy to miss. So why does this happen? It's because the world never stands still. User behavior changes. Think about how your own online habits have evolved over the last year. The data we feed these models shifts, what we call data drift. New patterns emerge in the world that the model has never seen before. And all those smart assumptions we made when we first built the model, they start to crumble. Imagine this. A model that was perfectly trained on yesterday's data is now being asked to predict today's reality. And unless you are watching very, very carefully, you won't even notice the gap that's forming between its predictions and what is actually happening. It's like a ship slowly drifting off course. And if you're not checking the compass, you'll end up miles from your destination without ever realizing it. This is exactly why monitoring is so critical in production ML systems. It's not just it's an absolute necessity. Monitoring helps you answer simple but incredibly essential questions. Is the data coming into the system still what we expect it to be? Are the model's predictions changing over time? Are those little errors starting to creep up quietly? Is the model behaving differently for certain groups of users? Without a solid monitoring system in place, your machine learning models degrade invisibly. The performance drops so slowly you might not notice it day to day. The positive business impact it was having starts to decline, just as quietly, and by the time someone finally notices something is wrong, the damage has already been done. You've been making bad decisions or showing users irrelevant content for weeks, maybe even months. And here's a key point. Monitoring isn't just about checking the final accuracy score. In many real-world systems, you don't get that immediate feedback. You don't always know if a recommendation was good or if a forecast was correct right away. So, you have to get creative. You have to monitor proxies, things that give you clues about the model's health. You look at the distribution of the incoming data, you track the model's confidence scores, you check the range of its predictions, and you keep an eye on the overall health of the system. This is why the best machine learning systems are designed with monitoring built in from the very start. It's not an afterthought that you tack on at the end, because honestly, retraining a model with new data is the easy part. The hard part is knowing exactly when you need to do it. This brings us to a fundamental truth about real-world AI. Production ML is an ongoing process. It's a cycle, not a one-time deployment. You build, you deploy, you monitor, you learn, and you adapt. Monitoring is what creates that crucial feedback loop, allowing your systems to evolve and stay relevant as the world changes around them. Without monitoring, you're essentially just guessing. You're flying blind, hoping for the best. But with good monitoring, machine learning becomes a controlled, iterative, and powerful system that you can truly rely on. That's why you'll often hear experienced ML engineers say that monitoring matters even more than the initial training. Training is what gives the model life, but monitoring is what keeps it alive, healthy, and effective. Thanks so much for watching. If you found this useful, don't forget to like and subscribe for more insights into the world of practical machine learning. See you in the next one.